Good morning. Today I'm going to show how to code particle swarm optimization in Python to solve function of one independent variable problem. Okay, which is find the best value for x that maximize the function fx equal to negative x squared plus 5x plus 20, where x is defined from negative 10 until 10. Okay, and then we use 9 particle with the x defined below here. Then we'll show the detailed computation for iteration 1, 2, 3, 1, 2, 3, and the same problem I have video it in my last video, but solve it using Microsoft Excel and MATLAB. Okay, hence first of all, the Python will be coded in a Collapse, Google Collapse. So first of all, you need to import. I think I clear all. I don't want to run all. Never mind. Okay, first import the numpy as np, and then you have here x. Going to assign the x value. So numpy.array. Okay, open the round parenthesis, the square parenthesis, assign the value of x, okay, separate by comma, print x to display the x value here. Okay, after that, given the x, okay, and here the function of x contain a maximum point. Hence, we are going to find what's the value of x and what's the value of x that yield this maximum value. Okay, and the same problem we can find the root. Okay, this is the root that obtained using mapper. We can use PSO to obtain the root of this function also. Okay, and then we have here iteration 1, x, where assign the x value, then we need to calculate f. So we define the function f is a negative x squared. So negative x star mean x times x plus 5x plus 20. Then you print it, you get the function value. Okay, tally with this is obtained using Microsoft Excel. Later on, we assign initial velocity as 0. So v equal to numpy.09. Yeah. Okay, later on, for initial iteration I equal to 1, or you may want I equal to 0. Local best, okay, LBP is a local best position. We let it equal to x. And local LBF, local best function or fitness function, we let it equal to f. Okay, so we go to find LBP equal to x. Okay, later on, LBF equal to f. Okay, after that, let's see, we have the GBF, the global best fitness function. Okay, for maximization problem, mean will be the maximum of the LBF, which is 26.21. So GBF will maximum of the LBF. They get 26.21. Okay, and GBP is a global best position which is associated with the GBF. So mean is here GBF is 26.21, GBP will be 2.3. Okay, so how to code it? Okay, so mean we need to know the index of the GBF, or the index of the LBF. To get the index of the LBF, we use numpy.arg max LBF comma axis equal to 0. We print it again. This is 5. Okay, the index for the Python start from 0. So this is 0, 1, 2, okay, 2 here, 3, 4, 5. So location, okay, of LBF that give the maximum value, which is number 5. Then we'll call back LBP at the location number 5. We'll give you, okay, the GBP as 2.3. Okay, that's why here the GBP in LBP, we want LBP this location number 5. Location number 5, which is from here. np.argument maximum LBF, comma axis equal to 0. That's why we get 2.3 here, 2.3. Okay, after that, to demonstrate, initially we use KW, the weight is 1, C1 is 1, C2 is 1. Okay, and then for to get the result in I equal to 2, okay, I will use a random number R1. Okay, first time I use 0.213, later on my R2 0.876. Okay, and then this is iteration 2, this is a R1 R2 value, iteration 3 I equal to 3, this is R1 R2 value, iteration 3 mean 2 3 4, I equal to 4, this is R1 R2 value. Okay, after that, okay, I will create the new, new V stand for the new velocity, new X, okay, the new X value, the new F, new LBP, new LBF. Okay, all contains 9 value because we create 9 particles. Okay, after that here, okay, since the problem for the manual calculation, actually using Microsoft Excel, we calculate okay 3 iteration, mean this is 1, so total is I up to 4. So we have 1 iteration, so I put it 3 more iteration. Okay, and then we on this one for compare with the manual solution. Okay, I will just calculate 3 more iteration, mean already I1, so 2 3 4. So using here is the velocity formula here. We need to update the velocity, so vi plus 1, or in the code Python coding here is my new vi. Okay, is you see here we got two for loop. Okay, the outer loop for j in range 3, because I'm going to have I equal to 1. Okay, mean the I in the slide will be tally with the j in the coding. Mean I will need 3 more iteration. Okay, and then for each j, okay, I in range of a length of x. We got 9 particle. So mean we'll calculate when j equal to 1, I will be 1, 2, 3, 4, 5. Okay, but Python start from 0. So I 0 to 8 here. Mean we have 9 particle. So for each particle, we are going to update the velocity. Okay, so we put up the formula for the velocity will be the W time VT. So mean VI, the new VI depend on the O velocity plus C1, random number. But for the compare with the manual solution, first of all, I will use, I will fix my R1 for when J1, R1, we have, this value, R2 also the same value. So multiply with LBPI, so minus xj. You see the formula. Where's my here? Plus C2. Later on we'll turn on this one. If later on we are make more iteration, the R1, R2 will make it random number. So you see so later on, according to the update the velocity formula, C2 time, C2 time the second random number multiply GBP minus XI. GBP minus XT. So mean when new velocity depend on the old velocity, the O not velocity, the O velocity, the O X. So you see here, new velocity W time O velocity time C1 time the first random number time the O, the O X, or the because X equal to LBP. So LBP, sorry, no, not LBP. LBP minus XT, so minus XI plus C2 time second random number time with GBP minus XI. So this one we update the velocity. Later on, you need to update the means in Excel. For I equal to 2, you need to calculate velocity according to the velocity, the new velocity formula. After you calculate the velocity, you need to calculate the x. Okay, the new x will be the OX plus the new velocity. So that's why new x is OX plus new velocity. So mean the x will be the OX. So in the previous table lah, OX. Okay, I'll show you the Excel. This one actually in the previous video. You see the new x will be the OX plus the new velocity. Okay, and this is a velocity formula according here. Velocity will be W. Okay, my W in this case is 1. W times Vt. No, the previous sorry. Here W in this Excel W is 1. So the new velocity is equal to the old velocity. Old velocity which is E4 plus C1 random number C1 is B15. Okay, and then time, random number 1 we put it here, which is cell F15, multiply LBP. This is my LBP here, F4. Okay, minus previous x, which is C4. Okay, plus C2 here, C2 is cell D15 time, time random number 2, which is here, H15 time with GBP, here GBP minus the previous x. So mean in Excel also the same thing, you just key in accordingly. Only Excel you maybe can only show a limited iteration. So then you have here, so we are in Python here. So mean we put out the new velocity formula, the new x formula. Okay, after that we are going to calculate the new LBP. Okay, or the new LBF first, and then later on the new LBP. Okay, the new LBF actually for maximization problem, okay, will be the maximum of the current fx compared with the previous LBF. So mean here the new LBF is actually, you compare the new fx with the previous LBF. So for maximization problem, so which one is maximum? Of course 23.44 compared with negative 120.16. So this will be maximum. Then you in Excel you copy it down. Okay, after that LBP is actually the local best position corresponding to LBF. So mean, in Excel how we put out here, again we compare the current fx with the previous LBF. So if the current f for maximization problem, if the current fx greater than the previous LBF, hence the local best position will be the current x, will be the current x here. Otherwise will be the previous LBP. Okay. If my current f, which is D17, greater than the previous LBF G4, then LBP will be the current x, which is the C17, otherwise the previous LBP, which is a F4. This is we put in Excel, later on you drag it down. Okay, so how about in Python? In Python, we just put up the same thing. We will check, for maximization problem, if new the new f, f, which is actually the LBF in I equal to 2. If the new f greater than previous LBF, then the new LBF will be the new FI. The new LBP will be the new XI. Otherwise, the new LBF will be equal to the previous LBF. The new LBP will be equal to the previous LBP. Okay. And then, so this for loops, you see, you need to indent in. So we'll do repeat, initially I0, I2, 3, 4, 5 until all the particles are updated with all the new okay, velocity formula, okay, and then with all the actually we're in the coding, actually we new I1. First of all, you calculate the new velocity, later on the new x, and then we determine the new the new LBF, the new LBP. So the process is iterate until all the particle completed. Okay, after that I just want to print J, so J, I think better to tally here, J equal to J in range 3 means 0, 1, 2. So J is 1. I want here. This should be the J plus 2. Okay, to tally with the slide here. Here is a I2 will be J2 because the J in range 3 start from J0, 1, 2. So I want to print it. After you complete here I equal to 2, here print J equal to 2. Print the new velocity, the new X, the new F, the new LBP, the new LBF. Okay, after we print out this table, we are going to update the new velocity. We'll put it to the V, new X put up to the X, new LBP put into the variable LBP, new LBF put in the LBF. Okay, and then, so okay, when you see here, when this one complete the for loop for I. Then we go in here, but still inside J, J still 0. When I complete, so mean this table complete, we go to print out everything, we update all the velocity, X, LBP, LBF, and then we'll calculate, for J equal to 2, we'll calculate GBP. GBP is a global best position using the same thing. Okay, GBF, okay, you can calculate GBF first, is the maximum of the LBF. For maximization problem, will be the maximum of LBF. I can print the maximum function value is a GBF. Okay, GBP, GBP, you need to identify the maximum, the index that give the maximum value for LBF, which is here. This one. We give you a location of the maximum, we give you the location where the GBF happen, and then we call LBP at that location, we give you GBP. Okay, so print it, and then at the end, done this one, J will increase, just now 0, and then 1, 2. We just do 3 iteration. Okay, then I print it. So you compare this one, you can compare the result with the result that obtained. This is actually obtained using Microsoft Excel. You see, we check the first value, the X, the F, F correct, because if the V correct, X correct, the F is depend on the function that we key in, LBP, LBF. I will just check, for each iteration, J2, I check GBP, 2.362, maximum value 26.231. And then the next iteration here, we check J3, J is equal to the I here, maximum value function 26.231, 2.362. Okay, we can check maybe one velocity value 11.509 x 12.3343. Okay, this is I3. Later on in the Python is a J equal to 4. Okay, we check it. The last value 2.362, 26.239. We check one of the velocity value, J4, 4.4052, x is 16.7395. So of course, we're going to get the correct value. You need more to increase the iteration. So J in range of 200, I length of X, we still use 9 particle, but previously I just demonstrate the random number 1, 2 using 3 value only. So I better change this thing to here. I off this. Sorry, correct. So now I will iterate 200 times. Each time the random number will be random given by the coding. Then we run it. Okay, so very fast you get the result. You can scroll down here to see what's the result here. J199. Because if we put J plus 2 here, 201. Okay, so the maximum value, okay, look at here, this function is oh, something not correct. Let me check. The maximum value should be 20 something. Previously, what is the value there? Here 26 point something. Why 200 time not correct? Oh, because this coding here, ABS, this coding is to find the roots. Okay, never mind. So I turn back to here, change it to 200, then off this three random number only. We make it general. So here the function you see negative here, negative new x squared plus 5 new x plus 20. Okay, I run it one more time. Until j equal 201. Maximum function, what is 2 point something? Okay, let me check back. Okay, just now the value not correct, and after I restart and run all, see, I restart and run all, because maybe the memory mix up. Yeah, because just now maybe mix up with this one, the memory mix up. So okay, for maximization problems, okay, what I do is here, this one, the function negative the new xi power 2 plus 5 times new xi plus 20. So I run it for 200 more iteration. So the first iteration we have I1, so total j will display j until 201. Okay, and then for maximization problems, okay, you have the LBP numpy the argument maximum, so maximum of LBF. So we run it 200 times, you see the value makes sense, right? GBP about is it 2.50, maximum function value is 26.249. Okay, the bottom coding here is, remember that we can also use PSO to find the root. Okay, find the root. Okay, to get the root, okay, we can take the absolute value, okay, show you, because we take the absolute value, then and then we minimize it, okay. Let me show you in mapper. Hold on, mapper. And you see while waiting for the mapper, okay, we want to plot with plots. Restart, and then with plots to show all the function, and then we are going to plot 20 minus x squared, x power 2 plus plus 20. Let's say x negative 5 until 5. Yeah, is it correct? Sorry. 20 minus x squared plus 5x. Yeah. So increase the range. We want to get the roots. So we plot the absolute value. Mean the negative part will make it become positive. Okay, so like this. So absolute value, and then we use the PSO to find to minimize absolute value. Minimize absolute value of 20 minus because we the new xi times 2 plus 5 times new xi. Okay, and then so in that case, I think better I use another coding, because before this iteration I need the previous new fi. Okay. You see this one, import numpy as np. This is for to find the root of the function that contains a maximum value, maximum point. You see the same thing. Define the x. Define our function f. We take the absolute value. Then later on, when we minimize it, we can find what's the location of x. The root is actually what's the value of x when f equal to 0. So absolute value of negative x squared plus 5x plus 20. Okay, and then here we assign initial velocity as 0. Okay, prints let the LBP equal to x, LBF equal to f, and then if you want to see the GBF will be the maximum of LBF. Like here, first iteration, GBF. You can print the value, print GBF. So you have here 26. Because this one, we want to minimize, right? We want to find the root, so it will be min, minimize. Yeah. So in your Excel, if you want minimize, I will make a copy. Okay. So and then my f, in this case, if you want to find the roots, I need to take absolute value. So ABS. Yeah. So LBF equal to fx. And then for minimization problem, your GBF will be minimized. So will be this value. So the GBP actually in Excel will be manual, negative 2.6, negative 2.6. And then you go to C, Python. Okay, minimum is here 0.24. So LBP, we get the argument minimum, negative 2.6, correct? So maximization, this will be MAX, this will be ARG MAX. So you see is correct, negative 2.6. After that, this one, if we want to show 3 iteration only, but maybe later on we will show 200 iteration, create the new velocity, new X, new F, new LBP, new LBF. Then we will run 200 more iteration. Okay, for minimization problem, if the new fx now must be less than. Okay, mean the same thing here. I will check the LBF here will be minimized. In Excel, this will be minimized, right? We will compare, okay, whether the current fx compare the previous fx, which one is the minimum value? Then will be the new LBF. Okay, and then for my LBP, you will compare the current fx with the previous LBF. For minimization, will be less than. Okay, if the current fx less than the previous LBF, then okay, your LBP will be the current x position. Otherwise, will be the previous LBP location. Okay, so since this f less than 120, so the LBP will be the current x. Okay, then you copy it down. Okay, again, the GBF, you need to change it to MIN. Okay, and then minimum, which one? Here. So the GBP, this is Excel will be manual, negative 3.468. So maybe we check one iteration compare with the Python. Let's see. I run one. Close this statement on this one. And just check one iteration. Okay. So the condition for minimization, if the new function less than the previous LBF, then the new LBF will be the new F, the new F, then the new LBP will equal to the new X. Otherwise, new LBF equal to the previous LBF, new LBP equal to the previous LBP. Okay, we can check the value here, and then Microsoft Excel, make it smaller. I equal to here, right? See, oh, already number 2. Check this one. V 6.132, 2.9784 until the last one. Velocity V negative 11.0376 x, the first value, tally, and then let's say 1 2 3 4 5, number 5 1 2 3 4 5 tally. Okay, and then we check the GB minimum value. Go on, minimum value negative 9.3670, this negative 3.468. Okay, why the minimum value not tally? Okay, we check the minimum of the f value. It'll be f 0.239. Compare the Excel. Velocity correct, x correct, the function f. Oh, because the Excel here function, I haven't changed it to absolute value. ABS. So the minimum, okay, the GBF, the minimum value 0.24. Yeah, 0.24. GBP will be negative 2.6. Yeah, so minimum value 0.24, negative 2.6. Okay. We check one iteration. If Excel, if you want to check more, let's say we check two more iterations here. F, make sure I change to ABS, absolute value. Then we want to minimize the absolute value of the function. Okay. This one also ABS. And then here will be minimize, minimum value. Then copy it down. Okay, LBF here is a minimize, okay, a minimum value. Copy it down. Okay, the LBP, the okay, if statement will be changed to less than, then you copy it down. This one also you change to the less than, then copy it down. Okay, this will be the minimum. GBF will minimize, okay, minimum value of the LBF. This one, minimum value of the LBF. Okay, 0.24. So mean the GBP is manual. Okay, 0.24 here. So GBP, we okay, in Excel you got to locate it manually. Okay. So we are going to just now, let's say J plus 2 here. Okay, we check three more, range of three, run three more iteration. Okay, and then we see J2, J3, J equal to 3. We check with Microsoft Excel. J equal to 3. Excel is I. We check the GBF. Minimum value 0.24. GBP negative 2.6. J equal to 4 also. Same thing. You may check velocity at the J equal to 2, 3. This is 4. 4. Velocity, you see the velocity. Not the same. Okay, we see one by one. Okay, we check back again. Okay, the from J equal to 2. Oh, I know. Okay, hold on. I restart and run all. Okay, I will check whether the same should be the same random number. Okay, I2 is this random number. I3 this random number. Then 178,507. So now we check the output here. We first round correct. Then J3 we check the V 6.7448 correct. And then we check J equal to 4 2.5647 because sometime when you run it several times, I think the random number or the memory that mix up. Okay, but the GBF value here, you see here, velocity x 5.8414, GBP negative 2.6, GBF is a minimum value here 0.24, which is tally with the mean the in Excel you can in mapper f solve for x, so you can find, I think GBP is a x position value. You can find one of the root. The other root you can find only one of the roots. Okay, and then maybe we can turn to, let's say, 200 iteration, and then we don't fix the random number, we let it random. Then I better restart and run all. So you run everything. So until J200 01, you get the root. Oh, so negative 2.6239 something, the minimum value. Okay, so the root that you obtain here, not exactly same with Maple, because okay, for Maple this value happen when the f equal to 0, but here the f here still not exactly equal to 0, is a 0.0044, because okay, we find the root using by taking the absolute value of this f, and then we minimize this absolute value. Okay, and then the same coding, if you want to, if you just have a minimum, have a function that contain minimum value, then let's say your functions, let's say your function only contains let's say plot, you have a function that only contain a minimum value. Let's see here. This function contain minimum value. Then you just change the function here. Change this function. Then no need. When you need to change the function, okay, at here, don't take absolute. No need to take absolute value. Okay, what you take is remove your absolute value. Okay, where's the function there? X squared, so positive x squared plus 5x minus 10. Minus 10. So you change the f here, and then you also change it here. Then you may restart and run all. The x is a new x I new x I. Okay, they give you GBP is mean you want to the x is negative 2.52 and give the minimum value of negative 16.25. So mean this code, okay, PSO minimum, you can find the minimum value, okay, the minimum value of a function, and you want to find the root, then you take absolute of the function f. So the PSO max here, you can find the maximum value and its location. Maximum value of the f and its location happen at GBP. So this one is a minimum value of the function f and the location which is given by GBP. If you want to use it to find the root, okay, to find the root, then you need to take the absolute value. You need to take the absolute value of that function, then take the okay the minimization, okay, problem PSO minimization. Okay, with this, okay, thank you for your attention.